Okay, noted. Assalamualaikum and good evening, all my fellow students. So today we are going to discuss some topic in chemistry. Okay, this topic may be quite new for this year, especially of the new format. The electrolysis topic has been postponed to the next form, which is form 5. And this one is actually more preferable for the revision for form 5 students at this year. So it's okay. This is still can be all the fellow students that are taking chemistry. Either they are from 4 at this year, or they are from 5 at this year. So it doesn't matter. Still, it's just a simple topic from chemistry, which is I found that is quite interesting and quite problematic among students. But it's quite easy, just quite tedious. There is a lot of things need to be understood. But still, I'm going to explain as simple as possible for all the students that in order to figure out for students to score this topic. Okay. So first of all, before we dwell into the what topic that we are going to cover today, which is electrolysis, let's take a break, take a moment for a while, and appreciate this meme. Okay. So I really love chemistry. Chemistry is actually the most preferable science subjects that I really like to teach. Okay, and among other science subjects, I'm really in love with the chemistry because I do love science. In order to love science, I also love biology and also physics. But chemistry is like in the middle. Okay, it relates so much with the physics and also relates so much biology. So it's in the middle. So that's why I figured out that you need to be able to in love with this topic, with this subject in order to score the other science subjects. Okay, because really related to each other. And so the first picture that is Mr. B. Okay, that is actually your friend thinking that it was so cool to be a chemistry students. And this is the view from your teachers. So look at the picture. You look so good with the code and handling all the chemical stuff and whatsoever with all the experiments that related with the chemistry stuff. And the third picture, which is the view from your parents, because they think that the chemistry, the experiment or what so that they saw in the TV might, be a very troublesome chemistry, troublesome stuff doing in school. And if you go to the left, what society thinks we do, that very awesome, when you think the students thinking chemistry was like, wow, the student must be really good, must be really intelligent, you're like a future for the country, a future for the human nation and what so. Okay, so it's like so cool when you then heard that you are taking chemistry and you are chemistry. And next is what you and your friends, think that you are really doing. Just like you think that you're really good in this science subjects, but you think that you're doing so well, but that you're actually doing is actually just nothing. You're just doing the theoretical stuff, learning the theoretical, more learning on the theoretical compared to the experimental stuff. Okay? So it must be balanced. But in our level of education, we more on theoretical, learning on theoretical compared to the experimental. So you need to find a way to actually be good at both. It needs to be balanced. So that's only the way to appreciate the chemistry, to score the chemistry in a very best way that you can be. Okay, so this is little things about me. Okay, so electrolysis. Okay, my name is Miss Amy. Okay. Hi, Fatih and also the. Okay. Sorry, I cannot speak Malay because this class is for English only. Okay, but I will try to speak a simple English. Okay, so try to catch up that, right? Because I promised to speak English at this webinar. Okay, so I have 5.8 years experience, okay, in tutoring. So I also teach physics, chemistry, and biology. But my strength the most is chemistry. I love chemistry the most, and that is the first subject that I taught, and I find out that I'm really good in teaching chemistry. Okay, and I also teach other bunch of non-science subjects. Okay, at different level. Okay, but only SPA other than science subjects, and science subject also are teaching at a different level. Okay, so I can teach the class, the tuition for English, and also I can speak Malay and also be bilingual. Okay. So next, this is what we are going to cover. Okay, for Form 4 students at this year might find out that this is really non-familiar, not really familiar with this kind of word, but you are going to learn this on next. So don't worry, just trying to absorb as much as you can. You know, it's okay if you don't understand. You can always refer back to the internet, to the revision book that you've already bought. But the revision book only have on 4 topics, but it's okay. You can always, just learning the new things and Google things out in the internet, get familiar with that, get the early vision, the knowledge about you going further on to learning the chemistry subjects. Okay. All right. So before I proceed, you can always, say anything with the chemistry, anything. Okay, this is you can always do a fun game um, while learning the chemistry in order to get the mood to learning chemistry at the very best way. Like this, for example, or crab. Like that, I learned must be really hard subjects, but it's not really hard though. Okay, still much easier compared to the math. I guess so. Maybe some of the students think so. Okay, so it's kind of cool to find out the way to, have a playing around with this. This is the list of the atoms in periodic table. So get fun with that. This is not the only words that you can come up from. All right, so let's go further with the electrolysis. Okay, so first of all, we need to understand about the electrolysis. Lysis means decompose or separate. Okay, so let's before that, I found the internet. Okay. Sorry, technical problem came up. I don't know why. Wait, and something just came up. Technical problem. Okay, proceed. Sorry for that. Just something technical problem came up. Wait, I want to find my. Okay, let's proceed. Okay, so you need to understand about the linguistic of electrolysis, electron. So if you are also learning the physics, electron is something involving the electron. And when we're talking something that involves the electron, means that it involves the electricity. Okay. So in this stuff is actually a process. So lysis is more on process of decomposition, it's a separating process. Okay. So in short word that we can see that is a decomposition process of chemical compound known as electrolyte process through it. Okay, so just bear in your mind that this is just a decomposed process that let the electric current pass through it. When we want to separate or decompose the electrolyte, the chemical compound, which is we specifically call it as a electrolyte. Okay, and you need to remember about this one. Okay, when we're talking about electrolysis, it's actually the conversion between the electrical energy into the chemical energy. Okay, we also have another process which is not called as electrolysis. There is another that convert the chemical energy into electrical energy. The diagram is almost the same, just a slight few changes that happen. Okay. Sorry, yeah, I don't know what I don't know what's wrong with the intro. I don't know what's wrong with the WebEx also. So hopefully it doesn't continue to lag. Okay, so this is the basic diagrams of electrolysis. So if you cannot digest the meaning of the electrolysis that I just stated there, okay, just ignore it first. Okay, we will always revisit again. Okay, just absorb first. To remember when it comes to this topic is that figure, that diagram. You need to be able to sketch that diagram. Okay, so I come up with a beautiful 3D diagram. So this is not the 2D sketches, but you can. I don't have the 2D sketches, but I will show you later. I think I got. Okay, so you need to be able to know what for the new student that just about the electrolysis about these things just now. You can just digest about the diagram first. Okay, so electrolytes, this one. Okay, the one that in black color, the solid color that is called as electrode. Okay, and then electrode is actually just a medium for passing the electric current towards the electrolyte to another electrode. Okay, so it's just simply a conductor. Okay, so you don't have to memorize about the meaning of the conductor, about the meaning of electrolysis yet. Okay, it's barely asked in SPM question about the meaning of electrodes, but it always asks you the definition of the electrolysis. So you need to memorize about the meaning of electrolysis. Right? It's okay, you don't have to dwell on that yet. And digest on the diagram first. Okay, so we need the positive terminal, which is we call as anode. Okay, and we also need the cathode, positive terminal. So this is quite easy, but you need to be able to determine which one is anode, which one is cathode, and which one is act as a positive terminal, which one is act as a negative terminal. So just remember the one only, okay, which is maybe I like positive terminal because it's something positive. Okay, so I like positive terminal, so I remember the anode. Okay, you don't have to remember both of it because eventually your brain just going to digest and remember the rest. Okay, which is the cathode. Okay, and we also have the electrolyte. Okay, this is electrolyte, the liquid. Okay, the liquid inside of this jar, this basin is electrolyte. Okay, which is electrolyte is by chemical compound. It's just a substance, a chemical substance, okay, that can conduct electricity. Yeah, you need always to bear in your mind, it only can conduct electricity in a molten state or in aqueous solution. Okay, just either these two states. Okay, these two states only. Okay, it's either molten state or aqueous solution. What's the difference between molten state and the aqueous solution? Molten state means it doesn't have the existence of water molecules or water ions, but aqueous solution it does contains the water molecule or water ions. Okay, that's just only the two differences. Okay, and they also undergo chemical changes. Means that is electrolyte when conducting the electricity, the electricity, there must be some changes happen there. If there is no chemical changes, mean this is not the electrolysis. Mean the process just not success. Okay. Okay, we go to the next one. Okay, always remember that in electrolyte we need a freely moving ions. Okay, so molten chemical molecules always come out in solid. Okay, so first when you burn or you conduct the electrolytes in a solid, nothing happened yet. But when it melts into the liquid state, so it meltings, and then the changes will happen there. Okay, it means that in the solid form, there is no freely moving ions. Okay, and then it needs to absorb the energy. So if you understand about the basic of ch changing the phases between the gases and also the solid, okay, it needs to absorb the energy from the electricity, which is the heat, and then bring the electron, the ion itself, okay, to move. Okay, then when it starts to become a liquid. Okay, all right. Always remember the direction is must be from anode towards the cathode. Okay, if you can see my arrow there. Okay, always remember this direction. Okay, because this is very important. All right, so let's play with the electrolyte, okay, which is electrolyte that I play around here. What is an E.C.S? Free moving ion means that the ion can move around in the jar. Okay, so that is free moving ion. Okay, if in the solid, if you learn the basic chem, in the solid, the ions in the solid compound or chemical just tight, close to each other. Okay, it doesn't move around. But when in a molten state, which is in a liquid phase, the ions can move freely around the chemical substance. Okay, around the medium, which is liquid medium in the chemical substance. It just simply can move around in the basin in the jar. Okay, just as you can see in the this diagram. Okay, as you can see that there is a random ions there. The anion, the cation there. The anion stand for negative charge. Cation stand for positive charge. Do not mistaken this. Okay, this is also the common mistake for the new students that started to learn chemistry. Okay, they start to confuse. Okay, because ions that electric to anode must be opposite to the which is anode is a positive charge, so it must be positive opposite. So we call as an anion. That's why it come out like an ion for the negative charge. Okay. All right. So let's talk about the electrolysis of molten compound. Just remember this is the molten. Okay? This is the molten part. So when I say that this is this is the molten part, there is no H2O molecules there. Okay, there is O, there is no H2O there, okay, which means there is no OH. Sorry, what are you? So you need to bear in your mind that when we talk about the molten electrolyte, there is no the absence of this stuff. Okay, there is absence of this stuff. Okay. So the only ion that exists there is Cl minus, and Na plus. There is only two types of ions. Okay. Right. Do it in there. This one. Okay. So there is a few tips what you need to do, especially in exam, in learning about this chapter. I just list down all the possibility things or stuff that you need to do. Okay, if after you do these tips, this list, you're going to figure out that it's quite easy to answer the question paper later. Okay, this is actually quite easy steps. So the first step is to list down and draw all the possible ions. Of course, the first thing you need to do is draw the diagram, the simple sketch of diagram, and then determine what to be the cathode, what electrode are going to be the anode. Which is cathode stand for the negative terminal, and anode stand for the positive terminal. Okay, and then you draw the ions there. Okay, and you list down. So just in the diagram, decide that the Cl minus ion going to attracted to the electron, anode electron. And for the sodium ion, it will attract it to the cathode electron. This is always opposite charge. Okay. After you do all the list down and draw all the possible ions, second thing is you need to define the flow of current. You always remember from the positive terminal to the negative terminal, which is from anode to cathode. Okay, always remember this one. All right. After you did this, define the flow of current, you need to do the chemical equation at anode. Then you need to decide its observation that happened there, okay, the result near the electron, okay, and also the products, okay, what you can, okay. So is there the electrode at the cathode is thinning or it become massive, or maybe there is some bubble happen there that be released, or there may be slightly changes of color. Okay, that's what you need to observe. Okay, so you do the chemical equation first, and then you do the observation. Okay, this observation you need to do a lot of exercises in electrolysis. Then you can always remember about the observation. Okay, do not mistaken the observation with the product. This is two things that the student always mistaken. Okay, when the question asks you to answer what is type of the product, and then you give the answer of observation, which is you define the color, you define the shape, you define the mass. Okay, it corrodes, it become massive, silvery metal deposited. Okay, that is observation. There is no way the answer for the product. Okay, the product is what define that observation. Okay, for example, there is a bubble happen near to the anode cathode. Okay, I can see there is some bubble being released. There's a colorless bubble. Okay, then I define that. I realized that from the chemical equation that I just wrote is actually an oxygen atom formed. So I can conclude that the oxygen atom is formed ions. Okay, so we will see later the answer for this one. Okay, so let's just digest about the steps that you need to do before you answer the question in SPM or any exercise when involving the electrolysis. Okay, so the fourth step is to do the same thing, just like the step 3, but this time at the cathode. Okay, so just now you just do at the anode. I always love to do at the anode first. Do not ever begin with the cathode. Why? Because the movement of the current is start from the anode towards the cathode. So you need to find out or write down the chemical equation first first at the anode, then you can decide what's going to happen in the cathode then. Okay, so for example, this the answer is, okay, do the chemical equation first. I will going to teach you how come the chemical equation becomes like that. Why the arrow there must be wrote first, okay, and then followed with the electron. Why not just electron first, then follow with the arrow? Okay, so this is the always common mistake that students love to do. Okay, so I figure out this quite not really shame, quite sad. The student not be able to write the right half equation. Okay, so let's absorb first, digest first the answer of this 3 steps. Okay, this step 3, which is for the observation happened there, is I can see some yellow greenish gas being released, or you can say there is some yellow greenish bubble that being released at the anode. Okay, so I can conclude that there is chlorine gas being formed at the anode electrode. Okay, because it's basically just based on the chemical equation that I just wrote down. Okay, and the 4th step is what happened there. This is the half equation. Okay, and then the observation is silvery white metal deposited. Deposited means that there is something attached to there is something other than metals, kind of metal that being attached on the surface of the electrodes. Okay, so we call it as a deposited. Okay, so we always use this word, and then we can conclude that from the half equation, so the atom form. Yeah, I should not do the chemical equation. I should do the half equation there. Okay, just find out my mistakes there. Do not make that mistakes. Okay, this is actually half equation. Okay, so let's learn to do the half equation. Okay, to do the half equation, you just need to remember this one. Yeah, I show you first the chemical equation that we just got from the previous slide. Okay, so first of all, at the anode, since you always know that the current is starting to move from the anode towards the cathode, means that at the anode there is something donating happen there. Okay, so when you learn, I bet you already learned about the how about the reactivity or electropositivity of metals, which is if the metals can donate the electron, means that it's very reactive, and we call that it has higher electropositivity compared to the one of atom that love to receive. Okay, so when the atom love to donate, it becomes an ion. Okay, it loses 1 electron. It kindness to donate the 1 electron, we simply say the charge is +1. Because positive, so +1. Okay, and it vice versa with the accepting. Okay, accepting is really not good for you in life, just to accept something. Okay, it's better to give in. There is a more positive way, or something good did, you got reward for that, compared that you just accept for beautiful kindness. Okay, so always remember at the anode positive terminal, there's always donating charity happen there. Okay, always donating the electron, which is the ion donating the electrons. Okay, so arrow must come first. Okay, so like that. Okay, the arrow must come first. Okay, so because due to the figure just now, as you can see there, the existence of the Cl minus, Cl ions. Okay, so we must write first the Cl minus, okay, and then follow with the arrow because it donates. Okay, it donating the electrons. Okay, and then after you put the arrow, you need to remember that it donates. For the negative charge, when it donates the electron, it will become gas or atoms. In this term, not atoms. Chlorine simply exists as a diatoms, which is required as molecule. It cannot exist as a monoatoms, which is only one single atom at a normal condition. Okay, so it must be exist in the gas form. So we write down Cl2. Okay, so and then plus 2 electron because it's the electron. So together at the jar, it will form this chlorine gas near to the anode electrode. Okay, so that's why the half equation becomes like that. It's quite easy. When it donates, then the arrow comes first, then it becomes the molecules together, giving the electrons. Okay, and then don't forget to balance that. Okay, because Cl2 is very important to balance in chemistry. Any equation, very important to balance. Okay, so means that there is a 2 Cl ions that need to be oxidized, that need to be used in order to make up one molecule, which is Cl. And then automatically it will donate to 2 electrons. Okay, so this is what we call, or this is how we write down our answer in the SPM if they ask you in terms of the sentence. If chlorine ion is oxidized, there is some grammatical error there. Must be being oxidized, or you can say just simply being discharged to chlorine atom. Oxidized means that it loses electron. Okay, we're going to come on that learning later, but I'm not going to include in this webinar because there's so much things to explain. Okay, you just digest first. Okay, for the SPM student, I bet you already understand about this one. Okay, to revise, recall back the basic one. Okay, all right. So let's look at the there's the number 4 is actually how come it becomes electron first, then followed by the arrow. Okay, so always remember the existence of sodium ions. Okay, so if at the anode already donating, of course not at the it must be setting happening there. Okay, that's only the way that it can be balanced. Okay, so when at the there is a cathode, no, my mistake. Just that I forgot to correct that mistakes. Okay, so it's supposed to and should be negative. Oh, I bet there is must be some mistake at the following. Some mistake at the following slide. But it's okay. Okay, do not mistaken there. It's right because we know. So the electron must come first. Okay, that's why the half equation becomes like that. So when the sodium ions accepting one electron, it will form the atoms. Okay, that's why there is some changes, some silvery whitish metal you can see on the surface of the ion. Okay, so we can just say that sodium ion is being reduced or discharged to the sodium atom. Okay, so this is another form for you to understand the movement. This is the freely moving ion. Okay, this is the freely moving ion, what we call it. That it can just moving around freely. There is no restriction. Okay, there is a net there. Reading that. Okay, so as you can see that I just explained to you that there is going to write down the steps, the answer in the SPM, for instance. Okay, this is how you're going to do. Okay, first stated that they at the positive terminal, what is the half equation followed by the observation. Lastly is the product. You do not twist up between the observation and product, the answer for the observation, because observation is something that you can see. Okay, product is that you verify that observation. All right, and this is for the negative terminal. Okay, so observation is silvery white metal deposited because there is a sodium atom formed there. Okay, The question asks you only to, sometimes the question only asks you to, okay, write down what is the half equation at the negative terminal. And then state the observation, the observation that you stated in the question below, above. So this is there because so the atom form. That's why this red white metal being used. Okay. All right. This is the color. Okay. It's very important for you to chemistry. You know what is the most tough in chemistry because you need to memorize. You need to hafal all mistakes, the color, the physical of the chemical compounds. Okay. The chemical, the atoms, especially the molecules, the compound, what it looks like, what is the color of iron, what makes up the color of the chemical compound becomes blue, for example, is the absence because the presence of copper ions. Okay, so this is white of sodium atom, and this is the color of the yellowish green of the chlorine gas. Okay, so get familiar with that things because it always come out in the SPN, always come out in the exercise also. Okay, it doesn't really ask you to do the electrolysis, the step of the electrolysis with some unfamiliar random electrolyte or chemical compound. You always come to the same chemical compound. Always the same, yeah. I can tell that. I can bet that. Okay, so we do another example. This time we use potassium bromide. So let's do all these steps. List down and draw all the possible ions. I already draw and listed down all the list of possible ions. There is only two existence of the ions, which is K plus and Br minus. And then you need to define the flow of current, which is the flow of the current. It must from the anode to cathode. So it always changing the position of anode and cathode. Sometimes this is anode, this is cathode. This is anode, this is anode, this is cathode. Okay, so do not hafal, do not memorize the position. Do not always stick that the position of anode is at the left side. No, you need to hafal the symbol that is positive. Either direction, it must come positive. The direction of the electron must come from the positive. It doesn't mean that the positive is in either position. It's either in the left or the right. Okay. So list down. Do the half equation at the anode and also the observation ups. And that is the answer. Okay. Always remember donating. So the Br minus will come the arrow first. It will donate as a bromine gas. Okay, so you can see that the reddish brown gas will release. There is some smoke, okay, that in a reddish brown color. Okay, that prove that the bromine gas is being formed. Okay, so how about at the cathode? Same thing, just different that the type of the atom, the metal, which is this time we use potassium. Still the same. The observation, which is silvery white. Okay, more or less okay. And magnesium, sodium, potassium, calcium always come from silvery white color. Okay, except for the aluminium and the argentum or silver, it always come as a silvery. Okay, except for the copper metal, it's actually brown in color. So this is the color, what we call as a silvery white. Okay, it's nothing that you cannot tell much difference from the silvery appearance, right? From the aluminium or the silver. But if you get used with this color, you actually can detect the differences between the silvery metal and the silvery white metal. Okay, this is the color of the bromine gas. Okay, so after you learn about this, why we want to learn, why we need or we should to learn this electrolysis of okay, why we need to mess up our head just to learn about these things. You know, we need to do all these steps. We need to have a lot of stuff. You know, because of this, because we apply this in our daily life. Not gonna be able to get the raw. If let's say we need aluminium to make a thing, a drink can, right? The scientists or the industry need to provide the can, so it's much easier for us to sell to the customer, and it's convenient for us to use the aluminium. But we cannot get the raw or the pure aluminium metal on the earth crust, on the earth surface, okay? Because that exists in the bauxite form. If you're familiar with this, we always have the pollution back then. I don't know, I think it still happens in Pahang. There's a bauxite polluted at the Pahang. It's in a brick color, it's like orange or brown brick color like that, you know. It's very dusty, the area, so that is actually because of the mining of the bauxite. Okay, so we need to extract, or we need to eliminate the oxygen in order to get the raw aluminium. Okay, so first of all, of course, you need to draw the figure, but you don't have to draw. You still use the same steps. Okay, same recipe, how the figure looks like. Okay, all right. As you can see that, first of all, you need to list down all the possible ions. All the possible ion is this one. Okay, it's quite easy to understand this figure. This is the aluminium. Okay, so there is only the exist of the aluminium ions and also the oxygen ions, right? Okay, so here we put the molten, which is the bauxite, and we add together with the cryolite. The function of cryolite, I'm going to explain later why they put together with the molten aluminium oxide. Okay, and then use the basic principle, same thing. Okay? At the anode, which is the donating of the electron will happen there. This is the will donates. Okay, here this one will donates at the anode. Here is anode. It will donates electrons. So these electrons will actually, okay, sorry for that, actually being accepted by the aluminium ion in order to form the aluminium atom. This is the final product that we want. Okay, so that's why the aluminium atom is quite high density. Okay, so it will sink at the bottom of this figure. Okay, and then it will flow out, and we will harvest this one. Okay, so that's how we use in the industry for the basic. Okay, okay, in order to melt, to make the form of the molten aluminium oxide, we need to heat the aluminium oxide so that it becomes melt. Okay. But in order to melt this aluminium oxide, it required very high heat temperature, so it's very costly. So scientists figure out that when they add the cryolite to this one, they add the cryolite, okay, it can reduce the temperature much better, and it saves much of the cost. Okay, because it's quite expensive to achieve a very high temperature baking. Okay, you need to burn a lot of petroleum or something like that to produce the heat. Okay, so it's very costly. So if I figure out this is the best way that we come up. Okay, so as you can see at the figure, okay, this is the answer. Okay. Except that there's a few things that need to be added up there. When you see that there's the bubble, this is the bubble happened there. Okay, at the figure you can see that there's like that. Okay, this is bubble. This is actually a bubble. Okay, a bubble of oxygen gas. Okay, they donate electrons. That's why they were first. And then I can see the color gas bubble appeared. Okay, but whenever you talk about the colorless gas, you need to test gas because before you can conclude that it's oxygen, there's another colorless gas which is hydrogen. How can you differentiate between the oxygen and hydrogen? It can be oxygen, it can be the hydrogen. So you need a test. So the observation answer always together with the test. Okay. So the test for the oxygen is handles the glowing wooden spoon. Need to hafal this one. Memorize this glowing wooden spoon for the oxygen. It will relight up or rekindles the glowing spoon, and that's how we can conclude that the oxygen gas is involved. Okay. So the next is answer for the steps 4. Okay, it's very methodically positive. So the observation for the physical appearance for the aluminum atom is silvery metal, not silvery white metal. Okay. Okay, I need to be fast. I'm running out of time. So there's a current line serve as a solvent for the molten side and increase the conductivity solution. Okay, so this is the kind of form of the aluminium. Okay, it's quite different. Okay, see, next is electrochemical series, E.C.S. Okay, this is you need to have fun. There's so much to you to memorize in the chemistry. But trust me, when it's actually just give it yourself a time to memorize. Okay, just give your time to memorize this one. Okay, in order to being able to really memorize this stuff, you need to do a lot of exercise. Okay, do this kind of exercise. Okay, this kind of exercise, do this kind of exercise. Okay, do different types of electrolyte, different types of chemical compound. Okay, so you need to have all this one. Cation ion, the list that way it goes down to the list. Why we need this electrochemical series when there is two types of anions or two types of cations is existed in an electrolyte. So we need, there is only one ion that can discharge. So how we choose that? The position of the that ion, when the position is much lower compared to the other ions, we choose the position that much lower. Okay. Okay, that one that might be selected and discharge. Okay, this is only applicable in aqueous solution ion discharge selection. We need to select which one. Okay, so the lower the position of the ion E.C.S, the easier ion will be decision. For example, that if I have H plus and CuPo plus, CuPo2 plus, which one that will be discharged? The lower position one, which is CuPo2 plus. Okay, same goes with the anion. Okay, so this is the electrolysis of aqueous solution. Okay. Again, do all the lists. Okay, just now we do for the molten. So always remember, this is aqueous solution, not molten sodium chloride. Okay, so when in molten, it's different. Okay, because there is actually 4 existence of the ions. Okay, which is OH minus, H plus, Cl minus, and H plus. Sorry, Na plus. Okay, so Na plus, H plus, OH minus, Cl minus. Okay, so between the OH minus at the anode, we choose the OH minus because of the position in E.C.S. electrochemical series is much lower compared with the Cl minus. Okay, if you don't believe me, see Cl minus is much higher compared to the OH minus. It's actually quite easy to remember the anion because whenever there is the existence of the OH minus always win because it's actually the bottom of the list of the anion. Okay, so we choose OH minus and do the arrow first because it donates the electron, and this is quite complicated equation. Okay, OH minus because we deduce the oxygen. Sorry, the O, it will become the oxygen gas, and we want to deduce the H to become atom. It must be a water molecule. Okay, it cannot be just hydrogen because it will combine together with the oxygen because it's very reactive. Okay, it's not stable just to be oxygen gas. When there is an existence of oxygen, there will be water. So it donates the 4 electron. Okay, and then there's the still color gas bubble appear. We can do the below display and also gas form. Okay, and same thing at the cathode, which is we have two choices to select, which is H plus and also Na plus, but we do not select the Na plus because the position of the Na plus is much higher compared to H plus. So we choose the H plus. So let's see the observation of the H plus. The colorless gas bubble appeared, okay, and pop sound being produced when we place near the lighted wooden spoon. Quite common test. We need to have all this one. So the hydrogen gas is being formed. Okay, so that's the answer. Okay, all right. Let's play around with the aqueous solution. Okay, draw the diagram first. Do all these steps. Okay, and for the sum of the electrolytes, actually, there's the 5th steps that included. Okay, this is quite tricky. It doesn't exist. It doesn't involve. Okay, in the NaCl or K₂Br electrolysis of that of those chemical compound. It only exists in the colored chemical compound. For example, the okay, because of the K₂ plus ion is actually exists in only the physical color for the K₂ ion is blue. So that's what makes up the chemical compounds to become fluid. Okay, so you need to determine the observation of electrolyte color and state the reasons why. Okay. All right. So let's. This is actually just a simple task now for guys to do. Okay. So we don't have really much response from the students. Okay. But it's okay. I'm just continue. Okay. Oh, I have only 7 minutes. Okay. I have to be quick. All right. So let's decide the current, the flow of the current here from the anode to the negative terminals, okay? And then let's do the chemical equation at the anode. So we will choose the OH minus compared to sulfate ion because the OH minus is always at the bottom of the E.C.S list, okay? So the OH minus at the anode will donate, or another term is loss of losing the electrons, okay, and it will form the oxygen gas and water, okay. But the only things that we can see physically is the bubble of the water. Okay, it's quite simple figure actually. And then we go to the cathode, conclude the half equation, which is the septane. So the septane will accept the electrons and will form the group. So we call it as a reduction, okay, or reduce. Do not bother about this reduction or oxidation yet, or the newcomer of the chemistry. Okay, I will explain later in another class. Okay, if you're interested in my class. Okay, so I just go to the basic of electrolysis first. Okay, so it will form the copper atom there. So the copper atom is actually brown in color. That's why see that it's a brown color. The copper plating of atom. Okay. it's quite easy. Okay. There is a fifth steps, which is the intensity. We need to define the clarify the color of the electrolyte. So the intensity blue color of the electrolyte will fading away. Why? Because the copper ion is being discharged. It's been discharged to the copper atom, so there is no longer, or the number of the copper ions is decreasing. So the intensity of the color is also decreasing. Okay. All right. So this is another diagram. Okay. It's the same thing. Okay. It just specifically explain to you more details. Okay. If you seems that it's quite troublesome to actually understood, you just need to take time and follow the steps that I asked you to do. Okay. So you can see that at the negative cathode electrode that there is a wrong. This is the color of the copper. You see, right? Beautiful, right? This is always become the thin color of. Okay, we go to the concentrated. Okay, concentrated still do the same thing. Okay, the only difference is at the anode. Instead, we choose the OH minus. We against the E.C.S because of the concentration of chlorine is much more higher compared to OH minus. So chlorine ions will win this time and will win discharge. So same thing as the previous slide, except still the cathode it becomes the same. Okay, still the H plus because we only consider the concentration of chlorine ion. When we say that the concentrated NaCl plus means that the chlorine is take place there in the concentration of chlorine. It always the anion, concentration of anion, which is the negative charge. Okay, so this is another figure. Okay, right. So you can see that the Cl is being released, Cl minus attached to the electrode, then being released. So chlorine gas. So okay, this is another figure. Okay, just make it simple for you guys. Okay. The last thing is electrolysis of a solution using reactive electrode. Okay, which is this means that the slash cooper means that we use two type of electrode. Just now we just only consider the inert electrode. Inert electrode means that there is an unreactive electrode. It doesn't affect the electrolysis process. Okay, it doesn't corrode. Okay, so but when we use the reactive electrode, it will have some changes at the electrode. Either that it will corrode or it will grow in the mass. Okay. Okay, still follow the same thing. Okay, the same steps. Okay, and don't forget about the fifth step because we are encounter with the copper sulfate color electrolyte. So we must have the fifth steps. Okay, so draw the diagram. This is an example of the diagram. As you can see that there is some changes at the electrode, okay, which is at the positive anode. Something happened there, which is the electrode is actually corroded. And then at the cathode electrode, suddenly the mass is increasing. The mass of the copper electrode at the cathode is increasing. Why? This is the answer. Okay. Because instead of the ions that you list down, which is SO42 minus, sulfate ions, or OH ions, either these two won't be discharged because there is a reactive anode there. We take the reactive anode, which is copper atom. Okay? The copper atom, the one that will donate the electron itself will form as ions. Okay, so must remember the arrow first. So the observation is the mass of copper anode electrode decreased because of copper ions form. Okay, harapan at the cathode. The mass of copper cathode electrode increased. Okay, where does come this? from the electrolyte. Okay, so how come the blue color of copper sulfate remains the same? Okay, because as you can recall back that at the anode, there is a copper ions that been formed. Okay, it will replace the loss of the copper ions that been reduced or discharged to form the copper atom. So this is another simple word. Okay, the intensity color of copper sulfate remains the same as the concentration of copper ions in the electrolyte remains the same. Okay. Okay, this is half equation, same thing. Okay, copper. This is always when encounter with this copper sulfate with the copper electrodes. Student always to start the half equation. Okay, start with the copper atoms, donate. It itself be reduced, oxidized to become the plus. Okay, and at the cathode, this is cathode. Let me one first. Okay. So this one we say that the copper atom is being oxidized. Okay. It's not discharged, it's simply just charged. Okay. It's been charged, not discharged. Discharge is we want to eliminate the charge, but this one it been charged. Okay. We add up the charge. Okay. So this one same thing. The copper ions will discharge. This week you can use the word discharge or you can use the word reduce when it comes to redox. We will come later. Okay. So why we want to learn or what is the application of electrolysis using the reactive metals, the purification of metals. Okay, which is I use the impure copper and pure copper to get the copper. Okay, the copper exists in the world. Exists as impure copper. Okay, it being covered with something chemical atoms, other chemical atoms, okay, on the copper surface. So we get as an impure copper. Okay, so we need to eliminate the impure one. So this is how we do to eliminate the one. Okay, so list down again. Possible ion, define the flow of currents, do the chemical equation that are not, and don't forget determine the observation of right color and state the reasons why. Okay, so ta-da! Okay, as you can see that as you can see that, see this one. You see this one? That is what we call as the impurities. Okay. Always remember that. And there are not these copper atoms that will react. Okay. Not sulfate. Not. Even though it will attracted at the electrode anode here. Okay. Even though these two attract there, it's still not being chosen, okay, or selected to discharge. Okay, so we just use copper. So this copper that will be oxidized, okay, to become the copper ions. So the copper ion is being, this is copper ions, okay. So this copper ion is being released. Okay. All right. So that is the same, just the same as the previous slide. Okay. So as you can see that the figure. So the copper electrode at the anode is thinning, and there is impurities exist there. When you say that the observation of the anode, okay, the mass of the copper anode electrode decrease or become thinning, and there is impurities being deposited at the floor of the vessel. Okay. Then what happened at the copper? We finally get the copper atom. So this copper atom will we allow the growth of mass of copper. Okay, this is much simple word. Okay, another application is electroplating, which is I use the silver argentum and then on that. Okay, always be mind that Ag is located at the anode. Okay, same goes with this one. Impure copper is um, this one. Why I label this one first? Because this is at must be at positive. This must be at anode. Okay. So always remember that. That's how I do my notes. Okay. Remember. Okay. So this argentum must located at the positive anode. Okay, and this one must be located at the where is my anode? Okay. Object must located at the cathode. Okay, and we must use the same electrolyte as the active electrode that we want to cover of our object. So list down, do the 4 steps. Okay, basically there is no 5 steps because it's a colorless electrolyte is a colorless, so there is no use to do the 5 steps. Okay, so as you can see that the movement of the argentum ions to that is actually come from the silver nitrate. Move towards the object, so it will reduce. Okay, it will. Okay, before that we go to this one, the add anode. I think I just did this thing. This one on the internet. Okay, need to be a bit hurry. Okay, this is I got only a few like 2 or 3 slides. Yeah, just to finish. Okay, so focus here first. Okay, because it's a positive and I'm not so focus here first. Okay, so do the step from here, do the half equation, and then it must be argentum that been selected, not the H plus. Okay, not the Ag plus, but sorry, not the OH minus, not the nitrate ions. Okay, that being discharged at this electrode, but the argentum electrode that will react. Okay, so this is the equation, and then do the observation, which is the mass of argentum anode electrode is decreased because of the silver ions form, and that at the cathode here. So after that, this thing is being produced there, it will add up the number of the existing Ag plus in the electrolyte. Okay, so it will receive the electron and then form the argentum atom, which is silver atom, and then it will form the. You can see the observation there. So tada, for example, like key, the object is like key. You can electroplate the key with the copper, you will get the surface of the. Okay, or you can get that the spoon become silver. Okay. All right. So the half equations like this. This is half equation. It's the same thing. Okay. Always remember the arrow first. So the silver atom is oxidized to silver ion. And lastly is this one must be cathode. Okay. And then must be the electron first. So electron first. So it's reduced or discharged. Okay. So we come to the end of the slide of the webinar. So let's learn more about electrochemistry if you're interested to learn more. But if you're not interested, we still need to learn more of the electrochemistry. Sorry for that sound. There is another type of the diagrams that came up. We're going to learn electrochemistry. This is the field of electrochemistry. We just learned about electrolysis. This is the Daniel cell or the Bordel cell. It's Daniel cells. The difference only here, you can see the lamp, not the battery cells. Okay, instead, just like electrolysis before. Okay, so if you want to for me to teach more about this one, you can always register the online class. Okay, whenever to go. Okay, so before we end the webinar, let's appreciate this quote. Okay, life is a chemistry. Dilute your sorrow, evaporate your worries, filter your mystic boil. Your ego will get the crystal of happiness. There is no comma there. Let's read again. Life is a chemistry, so you need to dilute your sorrow and then evaporate your worries. Then don't forget to filter your mistake. And last but not least, you need to boil your ego. Means that you need to eliminate your ego by boiling it, and finally you will get the crystal of happiness. Okay? Some kind of advice, which is we can relate with the chemistry. I love this one. Okay, and this is a chemistry shaming. We not only have body shaming, we have chemistry shaming. Okay, if you are not a part of solution, then you are part of precipitate. Okay, so your choice. You want to choose to be solution, okay, solution, or you want to be a precipitate, aka problem. It's just a metaphor. Okay, life. Okay, don't be a problem, be a solution. But usually we want the precipitate to happen with chemistry, so it's like it's not really tender, but it's okay. So that's it from me. Thank you so much. So inshallah they will have another webinar. I'm not sure yet. I will have the Bahasa Melayu lesson webinar and also English webinar. So stay tuned for my webinar. I'm not sure when. Okay, you're gonna be informed in the website soon enough. So I hope you not only can have some information here, learning something new, which is from the chemistry side, but I really hope that you can see another part of the chemistry is you can always learn something useful from this subject to make your life much more better. Okay, so that's it from me. Assalamualaikum and selamat berpuasa. And don't forget to continue study the chemistry. Chemistry is fun. Okay. So that's it for me.